In this video, we're looking at a 5-gram bullet traveling at 300 meters per second. It becomes embedded in the 500-gram target that was already moving away at 5 meters per second. And we're going to worry about the coordinate system and that the symbol that we're trying to find. We'll put that in a minute. But let's just take a look at this scenario. We've got the bullet moving along here, and the target you can see is moving, and they're both moving in the rightward direction, which we'll call the positive direction. They're both moving along, and at some point the bullet impacts the target. And at that point the bullet isn't going as fast, the block starts to speed up, but there's this transition period, so we're not going to worry about that. But right after the collision doesn't take very long, then both the bullet and block are moving at the same speed. And then they move along at that speed, and we're just assuming a frictionless floor, or we're assuming that we're analyzing the before and after to take up a really short amount of time. So right there, just before the collision until just after the collision is taking a really short amount of time. So there's not much time for friction to act on the system and to remove momentum from the system. We're going to go ahead and take this over to here, and we're going to say that our initial condition was right before the bullet hit the block, at that moment just before, and then even though we've slid the block and bullet way out of the way, that final is really just after the collision, as soon as the bullet is inside the block and not going any further into the block. Alright, now we're going to fill in some of this information here. We're working on Chapter 8, Conservation of Momentum. Remember that momentum is a vector, so we do need a coordinate system. Okay, our coordinate system is going to be to the right, being the positive x direction. What are we trying to find? Well, we're trying to find v1f or v2f. We could just call it vf. Okay, so we can say that this is vf. And sometimes we can have negative velocities in these momentum problems, but in this case, since both objects are moving to the right initially, there's no way that the combination of them of the two could end up moving to the left. So we're going to have a positive value here. All of our velocities in the problem are given in meters per second, so we expect our final answer to be in meters per second also. Now we can write in our plan. What equation are we going to use? Well, we've got our conservation of momentum equation here, and this is just saying that the initial momentum is equal to the final momentum. Okay, this is just for a two-body problem where there's two objects. And then we just go in and we fill in the values. We've got 5 grams times 300 meters per second plus 500 grams times 5 meters per second equals 5 grams times, remember we're just going to call it v sub f, plus 500 grams times v sub f. Then we can look here and we've got grams, so that's not an SI unit. You could think we need to convert that into kilograms, but that's not true. We can leave it right in grams, and we get gram meters per second, and then here we get 2500 gram meters per second, and then that's equal to 505 VF. Okay, so we did a little bit of algebra there. Just like if we had 5x plus 500x, we could get 505x. Same thing here. And now we can divide both sides by 505. And I had some units there that got lost. That's supposed to be grams. And over here, 505 grams. So on the left side we have 1500 plus 2500, and that equals 4000. And we divide that by 505, and we get 7.92. So VF equals 7.92. And let's look at the units. Remember I said we did not have to convert. So we have gram meters per second in the numerator and grams in the denominator. So that ends up with an answer of meters per second. And so that's just fine. We did not need to convert everything into kilograms. Both of the masses can just stay right as they are in grams, and then it works out just fine in the end. All right. So, is the solution complete? Yes, that's all we were asked to find. So that's done. Is the sign of the answer correct? Well, we thought that it would be a positive number. It did come out positive, so that's correct. We already talked about the units. Is the magnitude of the answer reasonable? So we had an initial speed. This block was moving at 5 meters per second, and it got hit from behind, and so it makes sense that it's going to speed up. However, it doesn't speed up by a lot because the block, or target as they call it, is so much more massive than the bullet. So that absolutely makes sense. That's all there is to that one.